previously. Hi guys, my name is OG. Welcome to our show Probotix. In this show, we're learning about robots, and of course, we're also learning how to build them. We're going to be looking at a very interesting topic today. We're going to be looking at machine vision. It is true that cameras have become pervasive and they are featured in almost every of today's applications. Some of the popular applications that we have cameras featured include handheld cameras, phone cameras, surveillance cameras for security, also in robotics and also in food production. Up next, we look at machine vision. Machine vision based systems are smart systems. These systems rely on visual data which they process and they can make decisions with. Visual data used by these smart systems are provided by digital image data sets. These systems, they can gather data from a real-time video feed from a camera, or they can gather data from image files stored on a computer. Under the hood of these machine vision based smart systems are machine learning algorithms. Machine learning is actually an application of artificial intelligence, AI. These systems can learn and improve based on experience and without being explicitly programmed. Machine learning focuses on the development of computer programs that can access image data and can use that data to learn for themselves. In simple terms, machine learning helps computers make sense of exactly what it's looking at. That's just simple. Next up, I'll be training some models which I'm going to be loading on the Honor robot so as to be able to identify things that I've shown it. And for our project, I'm going to be using some free software tools which includes OpenCV and TensorFlow, which I'm going to be using to train our model. Hey, as you can see here, that training our models with machine learning algorithms is actually expensive and time consuming. Really. On a regular CPU, training our models will usually take about 2 to 3 weeks or more, depending on the complexity of our model that we are training, as this will usually take a lot of physical RAM and processing time. Luckily for us today, we can actually shorten that time in training our model by using some GPUs which we can easily rent online. So the next question is, what are GPUs? General purpose graphics processing unit. Is it graphics or general purpose graphics? Before I go on to talk about GPUs, let me show you some of the modifications I'm making to the Hunter robot. For our Honor robot, I'm going to be adding a camera just here. I'm also going to be adding a box which is going to hold all our electronics. I'm going to add in the Raspberry Pi, also a USB power pack. I'm also going to be adding a Bluetooth module for debugging and testing, and also a speaker that is going to output the sound from our robot. To make it clearer, this is what our robot will look like. The cam goes here, and all our stuff goes here in the box. So let's get to working. I start by disassembling the Honor robot and adding a camera module. Also, I'm adding a Raspberry Pi 4, 8GB RAM. What is a GPU? That acronym GPU stands for Graphics Processing Units. GPUs, compared to CPUs, Central Processing Units, are mostly used in 3D graphic applications because those applications are computationally intensive. GPUs are so called because of how they process computations, and they are done in parallel. The regular CPU performs instructions and executes instructions serially. That means that if there are a list of instructions, a CPU will usually execute instructions sequentially from top to bottom. Comparing CPUs and GPUs, a CPU may turn out to be slower compared to a GPU which executes instructions in parallel. Cores in a CPU or GPU can be likened to the number of workloads that task or tasks can be divided into. CPUs typically may have 2, 4, 8, or 16 cores. But for a GPU typically may have 1,000 physical cores. And some other GPUs are known to have up to about 3,500 physical cores. So you get the gist now. GPUs are actually expensive, and they may range in price from $6,000 to $14,000 for a GPU. Today, there are many online GPU platforms for training machine learning models, which you can actually rent and pay for a very, very small fee. for some other GPU online platforms, you can actually train your models for absolutely zero cost. For our project, I'm going to be using the Google Colab Pro, which I'm going to be renting and I'll be using to train my models. Next up, I'm going to show you a series of steps of how I get to prepare my image data set. For the first example model that we're going to be creating and training, we're going to be making a simple stop sign, which we're going to show our robot so that when our robot sees that stop sign, our robot stops. So I got some data from Google search, and also I took some photos with my mobile phone. For our training of our model, I've used a total of 4 days and I was able to accomplish about 25,000 to 30,000 steps. Next up, I download my train model from my Google Drive, and then I write a simple script on Python on my Raspberry Pi and write some few instructions to be able to tell the robot what to do when it sees a stop sign. So let's see how the program works. You can see that the camera detects a 99% accuracy. That means that the model was trained properly and it works very well on TensorFlow. In the next example, I get to train a model where I get to use a multi-class, where I get to use different objects, which we're going to show different examples to our model and get it trained so that our robot will be able to identify these different objects. After 5 days of training our multi-class model, we get more than 65,000 steps. At this point, I'm showing the robot the different objects which it identifies correctly and successfully, except one false positive. For our last model, come closer. Do you remember that we have a thief to catch? Do you remember that thief? In this last model that we're going to be training, we're going to be creating two classes. In the first class, we're going to be creating images of our thief from using a day cam and images of our thief from using a night vision cam. What is this? In all the different examples we have seen of our trained model, we can see clearly that machine learning algorithms are very central in making smart systems. Hey, I've still got very interesting modifications which I've made to the Honor robot and to our other robots which we have featured in the previous episodes, which I'll be showing you in the next episode. I hope you've enjoyed the show, and at this point we're going to draw the curtains, and I want to say thank you for watching our episode, and I'll see you in the next video. Bye.